Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to identify the Arrhenius acids and bases and whether to determine how or if they are weak or strong acids or bases. So let's get into this. So the first thing you need to know is what an Arrhenius acid and base is. Well, an Arrhenius acid is simply a substance that's going to increase the H plus concentration in your solution. So that would be an Arrhenius acid. An Arrhenius base is something that's going to increase or produce more hydroxide ion in your solution. So that's how you're going to determine what the acid or base is according to the Arrhenius definition. So if you're given the formula, a dead giveaway of an acid is that begins with an acid. It begins with H plus in the or H in the formula. So if it begins with hydrogen in the formula, that's usually a dead giveaway that it is an acid. I can't think of an example where that would not be the case. There might be one example. Maybe one example would be your hydrogen carbonate ion, which begins with a hydrogen but can act as a base and does act as a base. So I talked about that in my last video. But almost always, if the substance begins with a hydrogen, it's going to be an acid. Also, if you have the name, then if you find the word acid in the name, then that's a dead giveaway that it's an acid, right? In the same way that if you find hydroxide in the name of your substance, that's a dead giveaway that it's a base. Okay. For the Arrhenius definition of base, right, we said that it was to produce more hydroxides. So if you see a hydroxide or OH in the formula, right, of this is going to be an ionic compound, not a covalent compound, because if you have OH in a covalent compound, that's not going to be hydroxide. That's going to be your hydroxyl group for alcohols. So don't confuse the hydroxyl group in an alcohol with the hydroxide ion in an ionic compound. So if we're talking about ionic compounds, the hydroxide, the OH in your formula indicates that it is a base. Okay. Now, as far as strong and weak goes, the strong acid and base, they have a list. There's a list of strong acids, there's a list of strong bases. You need to know what's on the list. So for the strong acids, there's 7 of them. So there's going to be nitric acid, there's going to be sulfuric acid, there's going to be hydrochloric acid, hydrobromic acid, hydroiodic acid, and then you've got the perchloric acid and chloric acid. So those are your 7 strong acids. Anything not on that list is a weak acid. For the strong bases, the list is the group 1 metals with hydroxide. So if you have an ionic compounds with group 1 metal and hydroxide, that's going to be strong base. And if you have group 2 metals with hydroxide, that's going to be a strong base. Not all of them, but the list would be something like you have lithium. So if you go down the list of the group 1 metals, you got lithium, sodium, potassium, rubidium, cesium. So those metals with a hydroxide, those would be strong bases. And then you've got calcium, and then you've got strontium and barium in the group 2 metals. Those with the hydroxide are going to be strong bases as well. Anything not on that list is going to be a weak base. Okay, so let's now look at our list here and see whether it's an acid or base and if it's weak or strong. Okay, so here they're giving us a formula for the first one. So again, we're going to identify the acid by the fact that it begins with a hydrogen. And sure enough, it begins with a hydrogen. So this is an acid. And again, there are 2 groups of acids. There's your oxyacids and your binary acids. The oxyacids have the form of having hydrogen plus some polyatomic ion with oxygen in it. So here we have hydrogen with a nitrate ion. So this is an oxyacid. So this is indeed an acid. So now we have to decide if it's strong or weak. Is it on the list of strong acids? And yes, it is. This is nitric acid. That is a strong acid. So it is strong. Okay, B, we have lithium hydroxide. So here we're given the name, and in the name we have hydroxide. So this is going to be a base. Anything that really has hydroxide in it is going to be a base. So here we have a base. Now, lithium hydroxide. Lithium is a group 1 metal. So again, anytime you have a group 1 metal with hydroxide, that's going to be a strong base. So here we have a strong base. Okay, next we have K2CO3. So this is potassium carbonate. So anytime you're given an ionic compound that has carbonate in it, the carbonate is going to be a base. This is going to be a basic substance here. So why is that? So just quickly, I'll show you. This is the reason for this is because carbonate comes from H2CO3, or sorry, CO3. And so this is going to react with water it's going to give a hydrogen. And so you're going to have your hydronium ion. This is the same as your H plus ion plus, HCO3. This is your hydrogen carbonate ion. This also can lose a hydrogen. So if I have HCO3 minus, this can also lose another hydrogen to water, H2O. And so this hydrogen will be donated to the water here. So you'll have H3O plus again, plus what's left over is CO3 2 minus. Now this can go backwards. So you can go the other way. So the carbonate ion will take a hydrogen, right? In this case, you could take a hydrogen from water, right? Or hydronium ion, but more likely water. There's probably more water molecules than hydronium ions. So you have CO3 2 minus. That'll react with water as well to get back your HCO3 minus plus your OH minus. So this can act as a base. So anytime you have a carbonate in your ionic formula, it's going to act as a base. So that's going to be a basic compound. So this is going to be a base. And is it a strong acid? Is it a strong base or a weak base? Well, it's not on the list of strong bases, so therefore it has to be a weak base. And finally, we have hydrofluoric acid. So here we're given the name, and you notice it has the word acid in the name, therefore it's an acid. And then, is it strong or weak? Well, hydrofluoric acid is not on the list of strong acids. It may sound like it's a strong acid because we have hydrochloric acid, hydrobromic acid, hydroiodic acid. Why not hydrofluoric acid? Well, hydrofluoric acid is not on the list. So that is weak acid. And that, ladies and gentlemen, is how you determine or identify whether something is an Arrhenius acid or base and whether it's strong or weak. I hope this video helped you. If it helped you in any way, then please, by all means, like the video, share the video, hit that like button. Also, subscribe to my channel, please, and hit that notification bell. And when you do hit that notification bell, click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comments section. I would love to hear from you. If you have questions or comments, or if you have a problem you want me to go over, or a concept you want me to cover in a video, or a topic to cover, then I would love to do that for you. Thanks for joining me, and have a great day.